Hello guys, welcome to my channel. This is Jyotiswarup. In this video, we are going to discuss about the common properties of all electromagnetic waves, and I think in our previous video we have completed the electromagnetic spectrum. I have explained about this with an example, with a picture. So we are going to study in this video common properties of all electromagnetic waves and the properties and uses of different radio actions. And there are 7 under this, that is gamma rays, X-ray, ultraviolet radiation, visible light, infrared radiation, radio waves and microwaves. Okay, so let us see one by one. So what now first we'll look into the common properties of all electromagnetic waves. Before learning about the common properties, I would like to show you about electromagnetic spectrum. Okay, so this is the wavelength and this is the frequency. And this is gamma rays, X-ray, ultraviolet ray, and this is visible spectrum. And this comes infrared radiation, microwave and radio wave, and it must should be in an increasing order or in a decreasing order. Okay, so this is the increasing order from gamma rays to radio waves. It is the increasing order of wavelength. Okay, so you need to mention the increasing order or the decreasing order. Okay, so this is the increasing order of wavelength, and this is the increasing order of the frequency. When coming to wavelength, moving from gamma rays to radio waves, it is the increasing order of wavelength, and moving from radio waves to gamma rays, it is the decreasing order of wavelength. But when coming to frequency, moving from radio wave to gamma rays, it is the increasing order, and moving from gamma rays to the radio waves, it is the decreasing order under frequency. So this is the visible spectrum, and this gamma rays, ultraviolet rays and infrared radiation to radio waves are called invisible spectrum. Okay, now we will learn about common properties. Okay, now we will look into the common properties of all electromagnetic waves. So what are the common properties here? So electromagnetic wave do not require any material medium for their propagation. Like glass and water, they do not need any medium. And the second point is they all travel with the same speed in vacuum and air. Okay, and with different speeds in different medium. Okay, what is the speed? That is 3 into 10 power 8 10 power 8 ms minus 1. Okay, so this is the speed in air. So that are the common properties about all electromagnetic waves, and there is another common property, that is these waves are transverse in nature. Also, these waves are not deflected by the electric and magnetic fields. Okay, there is no occurrence on them by the electricity or the magnetic field. Okay, that are the common properties. Now moving to properties and their uses of different radiation. Okay, so first we will see about gamma rays. Okay, so under gamma rays, what are the properties and their uses? So when coming to the gamma rays, what are gamma rays? These are the most energetic electromagnetic radiations of wavelength less than 0.1 Armstrong. This is the symbol of Armstrong. Okay, now we will learn about the sources of gamma rays. So they obtain in radioactive emissions with the nuclei of radio atoms, which pass from the excited state to the ground state. Okay, that are the sources of gamma rays. Now moving to the properties. So here the properties of gamma rays are they can easily enter the human's body. Okay, human's body, and can damage it. Okay, it can damage and the damage is biological. Okay, so when gamma rays can easily enter human body, and when they enter the human body, there is a biological damage. Okay, that is about the properties. Now moving to the uses of gamma rays. Here they are used in medical science to kill cancer cells, and in industry to check welding. Okay, so these types of things such as killing cancer and also uses in some industries. Okay, that is about gamma rays. Okay, we have completed with it. Now moving to the second one, X-rays. What is X-rays? Okay, so here X-rays are obtained from a heavy and metal target of a high melting point when highly energetic. Okay, when they are highly energetic only. That is about X-ray. Now moving to the properties of X-ray. So here X-rays can penetrate through the human flesh but are stopped by the bones. Okay, they can fluctuate into the human body but they will be, or they can be stopped by the bones. That are the X-rays. Now moving that is about X-ray properties. Now moving to the uses of X-ray. They are used in detection of fractures in bone and teeth. If there is a fracture, okay, if there is a fracture in a bone or a teeth, this X-rays help us to show the shape of the fracture. So that are the uses of X-rays. Now moving to the ultraviolet radiations. By the name ultraviolet radiation, we can understand that they are harmful radiations. So here the ultraviolet radiations have the wavelength between 100 to 4000. 100 to 4000 watt, 100 to 4000 Armstrong. Okay. So ultraviolet rays have wavelength of 100 to 4000 Armstrong. Okay. Now moving to the properties of ultraviolet radiation. So coming to the properties of ultraviolet radiations are, they are usually scattered by the dust particles present in the Earth's atmosphere, and they also obey the laws of reflection and refraction, and we have already discussed about these laws in our previous video. I mean in our previous chapter of refraction on the plane surfaces. That is about ultraviolet radiation properties. Now moving to uses of ultraviolet radiation. So they are helpful in few cases such as surgery equipments or for detecting the purity of germs, also in producing vitamin D. Okay, vitamin D in the food of plants and animals. Okay, that are the useful uses of ultraviolet radiation. Now moving to the visible light. So here the visible light have a wavelength from 4000 to 8000 Armstrong. Okay, so they have 4000 to 8000 Armstrong. And what is the source of visible light? The source of visible light is a sun, electric bulb, flame, and many more are the examples of visible light. And what is the uses of visible light? The visible light is used in photography and in photosynthesis to see the objects around us. Okay, so in photosynthesis, the light, that means the visible light, that is sun. Okay, it is very useful in the photosynthesis process. That is about visible light. Now moving to the infrared radiation. Okay, so now moving to the infrared radiation. Here these have an electromagnetic waves of 8000 Armstrong to and 10 power 7 Armstrong. Okay, they have 10 power 7 Armstrong. Okay, and it was detected by William Herschel in about 1800. Okay, at the time of 1800 it was discovered by him. So that is about visible light. So here coming under visible light, what are the properties of sorry, not visible light, coming to the infrared radiation, what are the properties? Okay, what are the properties of it? Okay, so we have already completed about visible light, that is it was discovered by Herschel in 1800, that and also electromagnetic wave between 8000 to 10 power 7 Armstrong. Now moving to the properties of infrared radiation. So the properties here are, that is they travel in a straight line like light with a speed of a 3 into 10 power 8 ms minus 1 in vacuum. Okay, so as same as the light they have. Okay, so as same as the light they have they move in a straight path. And the second law is they obey laws of reflection and refraction. Okay, so reflection and refraction, that are the two properties obeyed by the infrared radiation. Okay, and now moving to the uses of infrared radiation. Here, infrared radiation are used for therapeutic purposes by the doctors, and also they are used as signals during war, as they are not visible and they are not absorbed much in the medium. So in they are used in the war purposes. That is about the uses of infrared radiation. And there is a harmful effect. Okay, there is a harmful effect under infrared radiation. What is that? A high dose of infrared radiation may cause skin burns. Okay. Okay, so now we will move to the radio waves. Here, radio waves. So first, here, what is radio waves? These are the waves of longest wavelength among the electromagnetic wave. Okay, they have the highest of wavelength under all electromagnetic waves, that is 3 into 10 power 7 hertz, that is hazard. Okay, that is, there is nothing much about radio waves. That the only point is they have a greater electromagnetic wave when compared to everything, and that is 3 into 10 power 7 hertz. Okay, and what is the uses of radio waves? So the uses is these waves are used mainly in radar communication and also in radio and television. Okay, radio and television transmission. That is about radio waves. Now moving to microwave. So now moving to the last point of this chapter, that is microwave. Here microwave have wavelength in the range of 10.7 Armstrong to 11.10 Armstrong. Okay, is it high? Yes, it's a high. That is 10 power 7 to 11 power 7 Armstrong. Okay, so that is about microwave. Now moving to the sources of microwave, these waves produced by electro device such as crystal. Okay, that is the source. Now moving to the uses of microwave. Okay, what is the use of microwave? So uses of microwave is that they are used for satellite communication, for cooking in micro ovens, or for radar communication. That is the use of microwave. Okay, by this so we will end up our video till here, and we will continue next video. Till then, bye bye, but don't forget to like, share and subscribe. Thank you.